We are looking at three major key attributes. One would be resolution, the other one would be environmental condition, and the third would be perception. Let's now start to discuss each of these independently. So the first, of course, is resolution. And obviously, one may ask, why does resolution matter in lost cargo detection? And there are many reasons for that. First, it affects the detection capability and ultimately the reliability of the decision making, whether we have detected or not detected a lost cargo object somewhere on the road. Then it affects the size estimate error. So we have a way to estimate the size of the object based on the image, and the lesser number of pixels, the higher the error in this size estimation. So that's a major issue. Now, the contrast coming from the background is always challenging with low reflectivity objects. So in general, more pixels are needed to detect the object. So it's again a question of resolution. The better the resolution, the better our ability to differentiate contrast from the object. Then we have the issue of partial pixel coverage. We might see the image by, say, 4 pixels, or maybe by 4.5 pixels or 4.7 pixels. That's what I mean when I say partial pixel coverage. And this is an issue. Typically, when we have partial pixel coverage, we have lower signal, and therefore, there's less likelihood to provide detection. And finally, failure of single pixel may affect the whole process. And obviously, the more pixels we have, the less of an issue is the failure of a single pixel. We can look here down to see the difference between the case of 2 pixels versus 4 pixels. So you see that in the case of 2 pixels, the object is barely detectable. We basically say this is a no-go case. Whereas we have 4 pixels, we see the image better. We can really detect now the object, and this is the case where we define it as a go. Going into the detailed calculation, let's look at the scenario of a car driving at a speed of 130 kilometers per hour, where the distance between the car and the object is 150 meters, and the height of the object is about 15 centimeters. Now, if we do the calculation and we assume a minimum of 4 pixels in the vertical direction, we come to the conclusion that the minimum angular resolution that is needed is about 0.0125 degree per pixel. And this is actually the minimum requirement. Actually, if we think of the grid of the pixel, which is not fully aligned with the object, that could be even more severe. And that's why we are typically defining the needed angular resolution to be in the order of 0.01 degree per pixel. So now we are looking at the different modalities and we ask, can they provide this required angular resolution? We start with the camera, and the camera is the market standard, of course, and even if you take a market standard automotive camera, they are usually coming with high resolution, which definitely fulfill the task, assuming that the environmental conditions allow. So if we haven't sufficient environmental conditions and sufficient lighting, from resolution point of view, camera can do the job. Now we go to a LiDAR, and the current state of the art in the LiDAR, they are operating with angular resolution of about 0.1 degree. So 0.1 degree is good, but it's not good enough for this specific use case that we have just mentioned. There is an order of magnitude missing between the need and the current capability. If we look at an imager radar, this is even more problematic because the angular resolution of a typical imaging radar is somewhere in the range of 0.5 degree. So 0.5 degree per pixel, that's not enough. We need much better than that. Going to the CEDAR platform, we are talking about 2 megapixels, and this is why TRIA CEDAR can provide the 0.01 degree angular resolution, which is really needed for the lost cargo use case.